Okay, so the equation of the least squares regression line is closest to. So that's using the scatter plot that we can see. So least squares regression line, that is always this y equals a plus bx, okay? Now, you know that a is essentially the y-intercept, and that is when x equals 0. So be careful, down here, that is not 0. So because that's not 0, we know for sure that this, so if you look up there, 67.2 is not the y-intercept. So we don't know what it is, but we know it's not. So what you can do is you look down, anyone that has that as the A, let's get rid of them. So 67. So now you can see I'm reducing my selection to 2. And if you look, the only thing different here is the B value. So we're going to go find the B value of the line. So the way you find the B is you can actually use y2 minus y1 over x2 minus x1. So I decided I'm going to use this point here because it sort of goes, the line goes through it. So I'm going to use 2 and 66, and I used this one as well, which was 4 and 64. So if I pop them in, if I go 64 minus 66 over 4 minus 2, I end up with approximately -1. So I'm going to go with that D is the answer, which it is, all right? So just pick 2 points that it goes through. With the next question, the coefficient of determination is that. So what you need to do, I always write above it r squared as soon as I see the determination, so I know. Now, they want you to find r. So r can be found by doing the square root of r squared, but you've got to remember it's plus or minus. You need to decide which one it is, because obviously we can do the square root of that number and we work out that that is 0.913, but you must determine which one it is, positive or negative, and we get it from the graph because we can see this is a negative graph, isn't it? Yeah? So I know it must be negative, so A becomes the answer. In a study of association between person's height and the body surface area in square meters, so they're measuring this in square meters and height in centimeters. The line, they've given you this equation. Which of the following is a conclusion that can be made from the least squares rule? Right. So when they say an increase in 1 meter body surface area, that means they're increasing that. That wording, we don't ever see that. We always talk about if we increase height, what happens to body surface. And if you have a look, that's in the second one. It says B, an increase of 1 centimetre. So if we increase this by 1, if you follow that by the formula, it would go up by this amount. So it means the body surface would go up by metres squared. So this is the answer. So what I would suggest you do when you're doing your exam, say you've said no to that and you've said yes to that, let's move on. And then when you've got time at the end to check, go back and check that these statements aren't correct either. But because that's another way of checking, and you won't redo the same thing, and hopefully you'd pick up if you've accidentally done it wrong. Okay, so with this next question, so you've got the x and y values here that Freya used for a scatter plot. To linearize the data, Freya applies a reciprocal transformation of the y. So they've told you what transformation you're doing. A reciprocal means a 1 over y. With the x being the explanatory variable, they want you to find the equation. So the equation would now be 1 over y. you'll get an A value plus a B value times X. So what do you need to do? Into your calculator in lists and spreadsheets, you would create an X list, yeah? And so say you're 1, 2, so on. You create a Y list, so 105, 48. And then what you do is you've got to make the reciprocal Y list. So in here, we'll write it equals 1 over Y, and it'll fill it in for you. And then when you go to menu, and you go stats and all that, and you get down to the linreg, A plus BX. Remember, your X list will still be X, but your Y list will be the reciprocal Y, or whatever. And then you go find the A value and the B value, and you pop it in, and you'll end up with A. It's definitely not D and E because they don't even have the 1 over Y, which we must have there. So you could eliminate those two and get down to a 1 out of 3. Okay, the next question. A log 10 transformation was used to linearize the data, and the least squares line was fitted, and they came up with this equation, okay? So what they did in their calculator, they created log 10 list for the Y before they did this. All right, so the equation used to predict, so we're predicting when X equals 1. When you're predicting with a transformed equation, I would suggest you always use solve. So always use solve. Just put solve and then type in the equation. So it's log 10y equals 3.1 minus 2.3 times x, which is 1.1, and just go comma y. Because that formula is a formula for log 10y, not just y by itself. So if you use the solve, you'll be able to get the answer, correct answer, which is E. So just always use solve. Doesn't matter if they're giving you an x or a y on a transform equation, just use solve. Okay, so the statistical analysis of bivariate data involving variables x and y resulted in the following information. Use the following information to calculate the value of R. So you've got to find R is the question. If you look up here, we've been given the other information. Now, if you remember we had those rules where we can find the B and the X value, A value using these formulas. So if you have a look, there's R in the formula. Now so this is the question. So we must be able to get these three. And if you have a look, SY is there, SX is there, and here I can see what the B value is. So I can type that in again. I might just use solve again, and I'll go 1.31 equals R times 3.24 over 2.33, and I'll go comma R, and I'll end up with R equals 0.94. So the answer is D. Okay, so might need to have these formulas handy, know where they are, so you can just quickly get to them. The next question, the least squares regression line was fitted to a set of bivariate data, and another least squares line was fitted with response the explanatory variables reversed. Which of the following statistics will not change in value? Now, their residuals would. So if you had looked at before, if you change the value, the residual's the difference in the Y value and how it's predicted. So this is definitely going to change. So we write that will change. The predicted values, well, the equation's going to change as well. So that will change. If you actually, this one, the correlation coefficient, that's actually the answer. The correlation coefficient tells us how the X and Y values sort of vary between each other. So even if you flick it round, they still vary the same amount, the same way. So this is the answer. You might just need to have this one in your book to know that. It just might be a fact you might not. Okay, with this next one, you did one of these in your SAC where you had to find the seasonal index over a couple of years. So there's definitely an instructions in your in your notes, and we did one over 3 years. So this one's only 2 years. So if you look at this question here, they've given you the actual sales for the 2 years, and they want me to find the seasonal index for quarter 3. So that means you have to find the seasonal index for each, both quarter 3s, and then average them out. So if you write your formula for seasonal index, so seasonal index is actual over seasonal average. Okay, so if I go to do the first quarter 3, if you look, so seasonal index would be actual 3.34 divided by the season average. So how am I going to get the season average? I'm going to add these up and divide by 4. So that ends up being 2.29. So I divide this by 2.29, and that one ends up being 1.48. And then you've got to do it again for this one. So this one's seasonal index. It's got an actual 2.54. Going to divide it by the seasonal average, which means I add these up, divide by 4, which is 1.58. Okay, I end up with, what do I end up with? 1.29. So here's the 2 quarter 3 seasonal index. So to get the overall one, I've got to add them together and divide by 2 because there was 2 years. The one in your book, we divided by 3 because we were doing 3 years. Okay, so C would be the best answer there. Okay, Daniel borrows $5,000, which he intends to repay fully in a lump sum after 1 year. The annual interest rate and compounding period for 5 different compound interest loans are given below. Okay, so when you are borrowing $5,000, so you're loaning. So when you have a loan, you want the lowest interest rate. You want the lowest because you don't want to pay. You don't want to pay back more, yeah? So you want the lowest interest rate. So really, and the thing you also want is you want it to be the least amount of compounds. Because the more you compound it, the more interest you'll get. Okay, so this is essentially effective interest question. So you can go and type them in your calculator, and if you remember the EFF, you put the per annum percentage, then you do comma, and then you write how many times a year. So because it's weekly, it would be 52. And if you did the next one, it'd be 12.8, 52. So out of these two, you can eliminate. Anyway, you've got to keep on going, and you'll work out. When it's quarterly, it would be effective 13.2, 4. Yeah? This one would this one's a higher interest rate quarterly, so we wouldn't want that. With this one would be looking better. So you probably want to see the difference between those two, but the answer ends up being for D. Okay? Check them all out, because this equals 13.41 when you do it, and so on. This one equals the effective interest rate of 13.64. All right. Okay. Now with this one, so the graph shows the value of an asset, as it depreciates over 5 months. Which of the following depreciation situations does this graph best represent? If you have a look, they're talking about flat rate. So flat in some of the answers. So flat rate is equal to when it goes down the same amount every time. Down same amount. Okay, so if you have a look here, see how that goes down one box there. And so does that. So that essentially is this is flat rate here because it went down the same amount the 2 times. If you look here, it goes down 1, 2, 3, 4. And then if you look here too, it goes down 1, 2, 3, 4. So that's flat rate happening again. If you look though, it's a bigger drop, isn't it? So it's a bigger drop. So there's been a increase in depreciation. So the best answer there is a flat rate with an increase in depreciation. So that is B. Just be really careful because I think if you look at that just quickly, it does look curved a little bit to your eye. All right, so what have we got to do? Because this was so poorly done. So what I suggest is we're looking at the little amounts that it's dropping. Have a look. Is it changing all the time? Then it would be reducing balance. If it's not, it's the same amount, it must be flat rate scenario. So just have a check. This is so poorly done, you're probably going to get one on your exam. Okay, so the next one, which of the following recurrence relations could model the value of a perpetuity investment? So if you look up a perpetuity investment, the interest earned equals the payment taken out, yeah? Because, and therefore, the value remains always the same, doesn't it, with one of them? So if you invested 100,000, it'll stay at 100,000. So because you want this interest earned to equal the payment, what we can do is we can go and work out. So this part here is the interest, calculating the interest. So if I do 0.0029 times our amount, if it's a perpetuity, you should get it to be 356. But when you do that, you actually get 348. So it's not that one. If you do this next one here, and you do 0.0047 times the original amount, which is 80,000, that's how much interest you'd earn on it. It ends up equaling 846, which is what the payment is, isn't it? So therefore, that's the answer there. So Adam has a home loan, which with a present value of 175,000, blah, blah, blah. Okay, with these ones, boys, we are getting near to the question 22. So we're getting later on into it. So you're probably going to be using Finance Solver. So I like to start going, all right, and writing down. If this is a loan at the moment, that means this is probably PV. And because the bank, it's a loan, it's a positive. He's taken that money, he's got that money from the bank. Okay, then we can look, we've got an interest per annum, so here's an I, and then we've got compounding monthly, so we know PPY equals 12. And his monthly payments, now a payment, so he's giving it back to the bank, so that's a negative payment there. So the loan is to be paid in 5 years, so because it's monthly, that would be 5 times 12. All right, but Adam knows that the loan cannot be paid exactly with 60 repayments of 3,200. To solve this problem, he'll make 59 payments of 3,200, then he'll adjust his final value. So remember when I said these scenarios way back, we always try to do the first part as a first scenario, then stop and move on. So what we're going to do is we're going to see what's happening after 59, see how much he still owes. So we're going to do N, 59 payments. We're going to put the interest rate. This is into Finance Solver. We're going to, so PV, it was positive, so 175,260.56. Payments, they're negative because he's giving the bank back that one. FV, that's what I actually want to know. because I want to know how much he still owes after 59. And if I do, and then it's PPY equals 12, and CPY is always the same, so it's 12. So if we look at this, at the end of 59 payments, months, he still owes this amount. But he still has to pay interest in that last month. So that's why we have to pretend it's a new scenario. So we're going to do this last month, still at the same interest rate. But now, PV, I'm going to use this one here. And I'm going to say what he still owes. So I'm going to pretend like he got the loan for that, for the last month. So that'll be positive. The payment is what I want to know. And FV, because now he's going to zero it off, because that'll make 60, and then payments, and then 12, and so we do that, and we end up with 3568. So E, something like that. Okay, now these amortization tables, they're not really done well, and you're going to get one, and there was one in the year before, and it was poorly done as well. So I'll send you them later. The ones of 2017 and 16 with the solutions already done there, but let's do this one. Okay, the amortization for a reducing loan with monthly repayments is shown. Okay, the interest rate for this loan changed immediately before the repayment number 28. So when this 28, this is where this interest, the rate has changed there. So somewhere there. Okay, the change in the rate is best described. Now, if you have a look, this amortization table is monthly, but they want your answer in per annum. So let's just be really careful with that. Okay, so what we have to know, we need to know what the original amount interest rate was, and then do then the next when it changes and find the difference. So if you go if you're trying to calculate the interest rate on an amortization table, so interest rate will equal percentage, will equal, you get the interest from a payment or in a month from a term or whatever, and then divide it by the balance before and times it by 100. This will give you, that would be what you can do. So if I go up here, I'm going to do this one. So I'm going to find the original interest rate. So here we go. I'm going to do the interest pay. So I'm going to do 967.08 divided by the balance before, which was 3256.78, times it by 100. And I end up with 0.42%. Then if I go and look at when it changed, which was here, so I'm going to do the interest, which was 102.26, divided by the balance before, and times by 100. So I end up with 0.44%. So essentially it increased, it went up by 0.02%, but that's per month. So per month it went up by 0.02%. If I want to get per year, I'm going to times it by 12. Yeah? So 0.02 times by 12 equals 0.24%. So the change is actually A. Next one. Okay, Mariska plans to retire 10 years from now. Her retirement goal is to have a balance of $600,000 in an annuity at the time. So when they say a goal of $600,000, that to me sounds like a final value, and that would be a positive because she wants her money. Okay, the present value of the annuity investment is at the moment this. So this is a PV, But because you're investing it, you're giving it to the bank. So it's actually a negative. And the interest per annum, so they're giving you I there. And compounding monthly, they're telling you PPY is 12. Okay, to make the investment grow faster, she will add $1,000 payment. So that is still giving the bank. So it's a negative payment of 1,000, okay? 2 years from now, she expects the interest rate of the investment to fall to 3.2. So we're going to see a change of 3.2, still compounding monthly. So it is expected to remain at this rate until she retires. So when the interest rate drops, she must increase her payment so that she reaches the goal, which is 600,000. So what will her new payment be? So what's going to happen? You always treat it as like two scenarios. So let's get the first scenario done first. So for the first 2 years, so we're doing first 2 years, let's see how much she has in her investment after the 2 years. So we're going to go N, 2 times 12. The interest rate in the beginning was 3.24. The PV, so she's already invested this amount. The final value, we've got payments. Payment. Now she's giving the bank more money to help it grow, so it's negative 1,000. And the FV, that's what I want to know, what's happening there. PPY, because at the end of 2 years, I want to know what's going on. So at the end of 2 years, this is how much she has. So what we're going to do is I'm going to then go and do the next scenario, which is the next 8 years, because remember it was 10 years in total. So 10 years, I'm going to do 8 times 12. Now this is where the interest rate changed, so I'm going to do this new one, 3.20. Now, how much is she investing now? That's where we're going to put this in, and it becomes a negative again. So I'm pretending she's investing that again. Now the final value, we know this, now at the end of 8 years, or the 10 years in total, we want her to have a positive in that she's getting back 600,000. Oops, sorry, I've missed it. Payment would be next, and that's what I want to know what that is. What does she need to make sure that her final value is 600,000? So we do that, and we get the answer of 1854 something. So E is the answer.